Imagine waking one morning to discover that an object from deep space is on a collision course with Earth. Scientists calculate its trajectory, governments monitor it around the clock, and the world waits anxiously for updated predictions. Then, almost as suddenly as the danger appeared, new calculations reveal that the object will safely pass by our planet. Humanity breathes a collective sigh of relief. That scenario unfolded in late 2024, when astronomers identified an asteroid roughly the height of a 20-story building. For a brief period, it carried one of the highest recorded impact probabilities of any newly discovered near-Earth object in decades. Fortunately, improved observations refined its orbit, eliminating the immediate threat. But that close call raises a larger question. What if our ancestors experienced something far worse, something so extraordinary that it became embedded in the myths, religions, and historical records of civilizations separated by oceans and thousands of years? Across the ancient world, remarkably similar stories appear again and again. They speak of blazing objects descending from the heavens, cities consumed by unimaginable heat, mountains shaken apart, and entire landscapes transformed in a single day. At first glance, these accounts seem like mythology, dramatic tales created to explain the unknown. Yet scattered across several countries are physical artifacts that have led some researchers to wonder whether those legends might preserve memories of real events. Consider 3 discoveries made in completely different places. The first is a clay tablet recovered from the ruins of an ancient Mesopotamian library in present-day Iraq. The second is an enigmatic bronze disc unearthed on a wooded hillside in Germany, decorated with symbols many believe represent the night sky. The third consists of archaeological remains near the Dead Sea, where evidence suggests an ancient city may have been destroyed by an event unlike any conventional war or natural disaster. Individually, each discovery tells its own story. Together, some researchers believe, they may point toward a single catastrophic event that humanity never truly forgot. Whether that conclusion is justified remains fiercely debated. This is not a story built on certainty, it is a story assembled from fragments, ancient inscriptions, geological anomalies, archaeological excavations, astronomical calculations, and scientific disagreements. Some pieces fit together remarkably well, others refuse to fit at all. Distinguishing between evidence and speculation is what makes this mystery so compelling. Our journey begins nearly 2 centuries ago in northern Mesopotamia, where explorers searching for one of history's greatest lost cities stumbled upon something they never expected. For generations, historians knew of Nineveh only through ancient texts. The Hebrew Bible described it as one of the greatest cities of antiquity, while classical writers spoke of enormous walls and magnificent palaces. Yet, despite these descriptions, many scholars gradually concluded that Nineveh had become more legend than history. No one could identify its exact location with confidence. Everything changed during the 19th century. French and British expeditions competing to uncover the civilizations of Mesopotamia began excavating massive earthen mounds near the modern city of Mosul. What they uncovered astonished the archaeological world. Beneath centuries of dust lay the remains of the long-lost Assyrian capital. Among its greatest treasures was not a palace or a temple, but something far more valuable, an immense royal library. Inside its collapsed chambers rested tens of thousands of carefully organized clay tablets, each inscribed with wedge-shaped symbols known as cuneiform. Together, they formed the largest surviving archive from the ancient Near East, preserving medical knowledge, royal correspondence, astronomical observations, religious texts, legal documents, and some of humanity's oldest surviving literature. Ironically, the library owed its survival to the very catastrophe that destroyed it. When enemy forces captured Nineveh in 612 BC, fires swept through the city. The intense heat baked the clay tablets as if they had been fired in a kiln, making them harder and more durable than before. Collapsing buildings then sealed the collection beneath layers of rubble, protecting it from weather, looters, and time itself for more than 2.5 millennia. Among those thousands of recovered tablets was one object unlike any other. It was circular rather than rectangular, small enough to fit comfortably in one's hand and covered with unusual symbols arranged in 8 wedge-shaped sections. Unlike the countless administrative records surrounding it, this artifact resisted easy interpretation. Scholars eventually catalogued it as K8538, later nicknamed the Nineveh Planisphere. For well over a century, specialists debated its purpose. Some believed it recorded astronomical observations. Others argued it was a ritual text connected to omens or religious ceremonies. Several competing translations emerged, each claiming to explain its mysterious markings, yet none achieved universal acceptance. The greatest mystery, however, wasn't simply what the words said. It was where the contents came from. Evidence suggested the Assyrian scribe who copied the inscription may not have understood the language he was reproducing. Instead, he appears to have carefully duplicated an even older document, one originating many centuries before his own lifetime. If that interpretation is correct, then the tablet preserved knowledge already considered ancient in the 7th century BC. For decades, the artifact remained little more than an academic curiosity. Then, 2 aerospace engineers looked at it from an entirely different perspective. Instead of asking what the words meant, they asked a different question altogether. What if the symbols weren't describing a story? What if they were recording the sky itself? According to their reconstruction, the star positions aligned with the tablet only during the hours before sunrise on that morning, as viewed from southern Mesopotamia. Naturally, they assumed an error had occurred. The calculations were repeated. The constellations were checked again. The viewing location was adjusted. Even after refining the inputs, the same solution appeared. If their interpretation was valid, the tablet was not describing events from the Assyrian Empire. It was preserving observations from nearly 2,500 years earlier. That possibility raised an even astonishing implication. The tablet may not have been in original composition at all. Historical evidence suggests the Assyrian scribe who copied it was reproducing an even older source. If so, the observations themselves could have originated from a civilization that existed thousands of years before the Library of Nineveh was ever built. The engineers then turned their attention to the most unusual section of the tablet. Only part of the inscription appeared to describe an ordinary sky. The remaining sections seemed to record the movement of a bright object crossing the heavens. According to Bond and Hemsel's interpretation, the object entered the sky near the constellation we know today as Pisces. It traveled toward the northwest at an exceptionally shallow angle before disappearing beyond the horizon. Unlike a typical meteor streaking overhead, this object's path appeared unusually low. The engineers estimated that it crossed the horizon at an angle of roughly 6 degrees. That seemingly insignificant measurement became the foundation of their entire hypothesis. An object moving at cosmic speeds and descending at such a shallow angle would not simply vanish beyond the horizon. It would continue traveling for thousands of kilometers through Earth's atmosphere. Using that estimated trajectory, Bond and Hemsel projected its path across a modern map. The line extended northwest from Mesopotamia. It crossed present-day Iraq, then Turkey, then southeastern Europe. Finally, after nearly 2,000 miles, the projected course intersected a remote valley in the Austrian Alps. The location was known as Kofels. Long before anyone connected it to an ancient tablet, Kofels had already become one of geology's enduring mysteries. At some point in the distant past, an enormous section of mountainside collapsed. The scale of the event was almost unimaginable. Roughly 3/4 of a cubic mile of rock detached from the mountain in a single episode. The peak itself dropped hundreds of feet, while debris spread across the valley in a massive landslide, several miles wide and more than 1,000 feet thick. Events of that magnitude are rare. What puzzled geologists was not merely the collapse itself, but the evidence left behind. Near the base of the slide, portions of the rock had melted. Not weathered, not simply fractured, melted. The glass-like material, known as frictionite, forms when rock experiences extraordinary temperatures generated by intense pressure and rapid movement. Some researchers argued that an exceptionally large landslide could produce enough friction to create these conditions. Others pointed to microscopic shock features found in quartz crystals, patterns sometimes associated with meteorite impacts. The evidence has remained controversial for decades. No explanation has achieved universal acceptance. For Bond and Hemsel, however, the Austrian Valley represented more than an unusual geological site. It appeared to lie exactly where the object depicted on the tablet would have reached the end of its journey. If they were right, the mysterious markings on a clay tablet copied in ancient Assyria were preserving humanity's oldest recorded observation of a cosmic impact. It was a remarkable idea, but it depended on one enormous assumption: that the object crossing the Mesopotamian sky had enough size and energy to alter an entire mountain. The engineers attempted to answer that question using the laws of physics rather than ancient history. Their calculations painted a dramatic picture. If Bond and Hemsel's interpretation of the Nineveh planisphere was correct, the mysterious object recorded on the ancient tablet was no ordinary meteor. According to their calculations, it was enormous. Their model suggested an object nearly 1 kilometer in diameter entered Earth's atmosphere at roughly 20 kilometers per second, more than 70,000 kilometers per hour. But what made this event extraordinary wasn't simply its speed, it was its angle of approach. Instead of plunging steeply toward the ground like most incoming asteroids, they proposed it skimmed through the upper atmosphere at an angle of only 6 degrees. That single detail changes everything. An object arriving so shallowly behaves less like a stone falling into water and more like a pebble skipping across the surface of a lake. Rather than striking the ground head-on, much of its immense energy is released into the atmosphere itself. The result would be catastrophic. As the object compressed the air ahead of it, temperatures could soar beyond those found on the surface of the sun.
A brilliant plasma envelope would surround the incoming body, creating a blinding light visible across vast distances. Anyone standing beneath its path would witness something unlike anything in recorded human experience. The night sky would suddenly blaze with daylight. A second sun would appear where no sun should exist. As the object continued its journey across the atmosphere, enormous shock waves would follow behind it, racing across forests, mountains, and valleys at supersonic speeds. Eventually, according to their reconstruction, the object reached the Austrian Alps. Rather than excavating a classic circular impact crater, Bond and Hemsel proposed that it disintegrated above the Kurfels Valley in an immense atmospheric explosion.
The energy involved would have been staggering. To understand the scale, consider one of history's best-known cosmic explosions. In 1908, an asteroid estimated to be only about 50 meters across exploded over the Tunguska region of Siberia. The blast flattened roughly 2,000 square kilometers of forest, toppling an estimated 80 million trees. Even today, Tunguska remains the largest confirmed impact event in recorded history. Now, imagine something dramatically larger. Because destructive energy increases far faster than an object's diameter alone, a body approaching 1 kilometer across would release energy thousands of times greater than the Tunguska explosion. If such an event occurred, it would not merely devastate a forest, it could transform an entire region. Bond and Hemsel suggested that the tremendous heat and pressure generated during the atmospheric explosion might explain several unusual geological features at Kurfels, including melted rock, extensive landslides, and shock-related mineral structures. Not everyone agrees. Many geologists argue that the evidence can be explained without invoking an asteroid. They contend that an exceptionally large landslide could generate enough pressure and friction to melt rock naturally, while some of the microscopic shock features remain open to interpretation. The debate continues because the evidence supports more than one possible explanation. Yet regardless of whether Kurfels itself resulted from an impact, another question soon emerged. Where would such an object have come from? Astronomers already had a possible answer. Rather than originating as a lone asteroid wandering through the solar system, some researchers believe it may have belonged to a far larger family of debris known as the Taurid meteor stream. Unlike a single asteroid, the Taurid stream is an enormous river of cosmic material stretching around the Sun. Scientists believe it formed after a giant comet fragmented thousands of years ago, leaving behind countless pieces ranging from microscopic dust to much larger rocky bodies. Every year, Earth passes through this debris field twice. Most of the material is harmless. Tiny grains burn up high in the atmosphere, producing the familiar Taurid meteor shower that decorates autumn skies. To most observers, they are simply beautiful shooting stars, lasting only a few seconds. But hidden among those countless grains may be larger fragments, potentially much larger. Unlike the evenly distributed debris found in some meteor streams, researchers have suggested that the Taurids contain dense clusters created by the gravitational influence of Jupiter. Over thousands of years, Jupiter's immense gravity may have concentrated larger objects into compact swarms, leaving long stretches of relatively empty space between them. That means Earth does not encounter the densest portions every year. Instead, our planet may pass through these concentrated regions only occasionally. If that hypothesis is correct, most years bring nothing more than harmless meteors. Rare encounters, however, could be very different. Supporters of the Taurid hypothesis point to several intriguing observations. During 1975, as Earth passed through one particularly dense region of the stream, seismic instruments left on the Moon by Apollo astronauts recorded an unusual increase in lunar impacts. Without an atmosphere to burn up incoming debris, the Moon provides a natural record of activity within meteor streams. Some astronomers argue that these observations suggest larger objects are indeed embedded within the Taurid complex. Others caution that the available evidence remains limited and requires further study. Either way, the possibility has been taken seriously enough to justify dedicated observation campaigns. Modern telescopes have repeatedly searched the Taurid stream for larger hidden objects. One of the most anticipated opportunities occurred in 2019, when Earth was expected to encounter another potentially dense region of the swarm. Astronomers planned extensive observations, hoping to identify any hazardous bodies before they approached Earth's orbit. Unfortunately, those observations were disrupted when protests forced the temporary closure of observatories on Mauna Kea in Hawaii during a critical viewing period. A valuable opportunity was lost. Further searches continued in subsequent years using additional telescopes. Those surveys found no evidence of exceptionally large objects lurking within the stream. At first glance, that sounded reassuring. However, researchers emphasized that failing to detect giant bodies does not eliminate the possibility of smaller but still dangerous ones. Objects only a few dozen meters across are capable of devastating a city. Bodies a few hundred meters wide could produce regional destruction on an unprecedented scale. Even if no mountain-size fragments remain, identifying these smaller objects remains an important goal for planetary defense. Fortunately, astronomy has entered an era unlike any before it. Powerful survey telescopes now scan the skies every clear night, tracking thousands of near-Earth objects and continually refining their orbits. Each new discovery expands humanity's ability to recognize potential threats years or even decades in advance. But our detection systems are not perfect. Some objects still manage to surprise us. And one recent encounter demonstrated exactly how vulnerable we remain. An asteroid approached Earth without anyone seeing it coming.
In recent decades, astronomers have become remarkably successful at tracking objects that pass close to Earth. Powerful observatories scan the sky night after night, identifying asteroids long before they pose any immediate danger. Yet, despite these advances, there are still blind spots. Objects approaching from the direction of the Sun, for example, can remain virtually invisible until they have already passed our planet. That is exactly what happened in December 2024. An asteroid roughly the size of a 20-story building slipped through one of those observational blind spots. It traveled between Earth and many of our satellites before anyone realized it had been there. The object wasn't discovered during its approach, it was discovered after it had already departed. A telescope in Chile eventually detected it moving away from Earth, allowing astronomers to calculate the path it had just traveled. The event served as a reminder that, despite decades of progress, our planetary defense systems are still incomplete. For a short time, orbital calculations suggested the asteroid might return during another close approach in December 2032. Early projections even left open the possibility of a collision with the Moon. Scientists viewed that possibility with cautious interest. A modern lunar impact would offer an extraordinary opportunity to study the effects of a collision on a surface that preserves geological evidence for millions of years. Further observations eventually refined the asteroid's orbit. Using data from the James Webb Space Telescope, astronomers determined that neither Earth nor the Moon was in danger. The object would safely miss both. Once again, improved science replaced uncertainty with confidence. Yet the episode highlighted an uncomfortable truth. Sometimes we only discover potentially hazardous objects after they have already flown past us. That realization brings the story back to another mystery, one rooted not in modern astronomy, but in archaeology. For thousands of years, one of history's most famous destroyed cities existed only in religious tradition. The biblical account of Sodom describes a prosperous settlement destroyed by fire descending from the heavens. According to the narrative, the destruction was sudden, overwhelming, and so complete that the surrounding land became barren for generations. For centuries, historians debated whether the account referred to an actual place or served purely as a moral lesson. No convincing archaeological evidence appeared. Eventually, many scholars concluded that the city itself may never have existed. One archaeologist disagreed. Dr. Stephen Collins believed previous searches had focused on the wrong location altogether. Rather than looking south of the Dead Sea, where earlier expeditions concentrated their efforts, Collins argued that the biblical descriptions pointed north. His attention eventually settled on a large archaeological mound in modern-day Jordan known as Tal el-Hammam. Excavations began in 2005. What emerged surprised even members of the research team. Tal el-Hammam was no ordinary Bronze Age settlement. During its peak, it ranked among the largest cities in the region, dwarfing many neighboring communities. Its defensive walls, public buildings, and extensive occupation suggested a thriving urban center. Then, quite suddenly, everything ended. The city contained a thick destruction layer unlike anything archaeologists expected. Instead of finding evidence typical of warfare, they encountered signs of extraordinary heat. Pottery showed signs of partial melting rather than ordinary breakage. Mud bricks displayed glass-like surfaces as though exposed to temperatures far beyond those produced by conventional fires. Grain stored inside buildings appeared to have been instantly carbonized. Laboratory testing revealed temperatures exceeding those produced by volcanic lava. Whatever happened there released an enormous amount of thermal energy within an extremely short period. The human remains were equally puzzling. Some skeletons appeared violently fragmented. Others seemed to have been exposed to intense heat almost instantaneously.
Researchers also reported microscopic evidence commonly associated with high-energy impact events, including shocked quartz, tiny metallic spherules, melt glass, and elevated concentrations of iridium. Taken together, these findings led one research team to propose a dramatic explanation. They suggested that an asteroid or comet exploded in the atmosphere above the city. Unlike a traditional impact crater, such an airburst would unleash an immense shock wave and intense thermal radiation without the incoming object ever striking the ground. The comparison often made was Tunguska. But according to the published model, the proposed explosion above Tal el-Hammam would have been substantially more powerful. The researchers estimated that the blast occurred several kilometers above the city, producing temperatures capable of melting construction materials and generating winds strong enough to devastate everything beneath them. Another unusual discovery attracted considerable attention. The destruction layer contained unusually high concentrations of salt. One explanation suggested that the explosion may have vaporized water from the nearby Dead Sea, carrying salt into the atmosphere before depositing it across surrounding farmland. If correct, this could explain why agriculture in parts of the region appears to have declined for centuries after the catastrophe. It is certainly an intriguing hypothesis, but it remains controversial. In 2021, a scientific paper presenting the Tal El Hammam airburst theory attracted widespread international attention. It also received significant criticism. Several scientists questioned aspects of the analysis, including portions of the impact modeling, interpretations of the archaeological evidence, and the presentation of certain excavation photographs. Following extensive review and public debate, the journal that originally published the paper retracted it in 2025. For many observers, that seemed to settle the matter. It did not.